Let's work through a simple example where we use raw data to build a frequency distribution table. So what I've done is I've created a set of data here, and this would be like some survey results, or in other words, your raw data. And the idea is we've asked people, how many siblings do you have? And so these are the answers that we get. Now, before I carry on and before I start to build the table, I just want to point out one thing before I get into it, and that's that what I've done here is I've deliberately chosen to work with what's called discrete data. Discrete data is, it means it's a variable. The variable in question here is how many siblings do you have. A discrete variable is a variable that can only take on specific values within a range. So if I'm asking people how many siblings do you have, you can only answer I have 0 siblings, or 1, or 2, or 3, or 4, and so on. You can't say I have 1.875 siblings. That would be continuous if I was able to answer anything within my range. And actually, let's have a look at what the range is here. If I have, well, obviously I have a minimum number of siblings of 0. And for this particular data set, it doesn't have, I'm not talking just in terms of the maximum number of siblings possible. I mean within my data set, I can see that 6 is my maximum. And so within this range from 0 to 6, people can only answer 0, 1, 2, 3, 4, 5, or 6. That would make this discrete data. And I chose discrete data because it makes this example work a lot more easily. Don't worry though, I will deal with continuous data as we move through videos that come after this, and also with grouped discrete and grouped continuous data. So I'll get into what those are as they come up in those videos. So for now, this is just a nice simple example working with discrete data. The values range from 0 to 6, and so I'm going to start to build my table. Now the table itself starts off with our x values, and I just want to be clear here when I'm actually, let's put that up a little bit higher so I have a bit more room. I want to be clear with this first column that I'm going to create here. What I'm going to put here are not necessarily the actual values that you see within your sample. Instead, this is going to be a scale of all the possible values that sit within this range from 0 to 6. I'm going to start with the highest, so 6, and then I'm going to work my way down to the 0. That's simply just the convention in your course. It doesn't have to work that way. You'll see plenty of examples where you start with low numbers and you work your way upwards, but the convention in your course is to start with the high numbers and work your way downwards. So I'll do that. And so what I was saying about this being just the scale and not necessarily the actual scores, the reason I say that is because I'm going to include all of the possible values, whether they appear in the data or not. For example, you will find as you scan through this data that there were no participants in the survey that answered that they have 5 siblings. But I still need to represent 5 in my scale. So whether or not you have the actual data represented in your sample, it needs to be represented in a scale. So this is a scale, this is not the actual values. After this, what it is I'm going to be working towards is listing the frequency for each one of these. So I need to know how many people answered that they have 6 siblings, and so on. How many said 5? How many said 4? To do that, I'm going to put in one column in the middle. Let's make this a bit easier. I'm going to put in what's called a tally before I get to my frequency. Now a tally is it's just like putting tick marks. So if I had 1, 2, 3, 4 people that said 6, I would put 1, 2, 3, 4 tick marks there, and then I would write the number 4. Why would I bother doing something like that? Well, what having a tally does, or what having this column does for you, is it allows you to go through the data one by one, starting at the beginning and systematically working your way through and recording each value, instead of scanning through the values looking for a number. So for example, if I had the number 6, the value 6, and I just wanted to jump right to frequency, what I would probably do is I would scan through looking for any 6s, and there's one there. I've got the little green mark underneath it, and so I would say that I have 1 6, which is correct. However, it's very easy using that scanning method to miss a value or maybe lose count of how many you found. Like, have a look at the ones. I've got 1, 2, 3, 4, 5, 6, 7. I might have missed one. I might have added one too many there, especially in a large data set. It's not a good idea to just jump right to frequency. What I would suggest is this. It might seem really oversimplified, but this will save you making a simple mistake, and you should get easy marks on a test for doing a question like this. You don't want to make a simple mistake. So watch how I do this. I'm going to switch my color to red, and then I'm going to go through my data one by one. So I have a 2. So my 2 has been crossed out, and so I'm going to add to my tally, I'm going to add a tick mark. And then I have another 2, and then another tick mark goes there. And then I have a 0, and so let's actually, yeah, okay, so I've got a 0, so I'll put a tick mark there, there's a 4, and so on. So you can see what's going to happen with tallies. There's no way I could miss a number, or it would be very difficult to make a mistake doing it this way. And then at the end, I can determine what the tallies are equals to. So that was another 2, and then I've got a 1, and a 4. Who said statistics wasn't exciting? A 3, a 0, a 2. Okay, so that means I've got 5, and then there's another 1, and there's a 4, a 4, a 4, okay, and a 1, and another 1, and a 2, and another 2, a 6, a 2, a 3, a 1, another 1, a 0, a 2. There we are. A 3, a 4, and a 2. Okay, so now I can take my tallies, now that I've gone through and I know that I've dealt with every one of my original data values properly. I can list my frequencies. So there is 1 6, there are 0 5s, there are 4 4s, there are 3 3s. I'm going to make this a little bit easier to keep track of. There are 10 2s. There are 1, 2, 3, 4, 5, 6, 7, 7 1s, and 3 0s. And so this takes care of building my frequency distribution table. So what you see here, this is all that I meant when I said I'm going to build a frequency distribution table. So that's the whole thing done. And that would get you full marks. You really just need to have 2 parts. You need to have your list of scores, or your scale on the one side going from highest to lowest and including any empty categories like the 5 here. I should point out that I call these categories because even though right now I just have single values like 6 siblings, 5 siblings, and 4 siblings, later on when I'm building other frequency distribution tables, each one of these categories could cover a span of numbers, like people who got between 10 and 20 on a test, and so on. Also important for full marks is I need to list my frequencies, and so we've got them there. The tally, that's just me showing you a technique for making sure that you don't miss any data or double count any data. You can see now that the table does perform its job fairly well. Remember, the whole purpose of a frequency distribution table is to give us a quick look or a quick summary of what's happening with the data. So there's 2 things immediately that I can see from my table here. One of them is the range is apparent. The range is easy to see. So I can see that my data ranges from 6 down to 0 siblings. So people reported that they had between 0 and 6 siblings. However, even though I have all of that range, the data tends towards, or it's clustered around the low end. And so you can see that right here, 1 or 2 siblings, that's where the majority of the data sits. And so that's apparent with my tally marks, that's apparent with the high frequencies. So 1 to 2 siblings. Oops. And that's all that we're really looking for. It doesn't do more than that right now. We will get more information from this table, and we'll use this table to build a graph, but very quickly it shows me what sort of a range of data I'm dealing with and where the data tends to be clustered, either in terms of my tally marks here, or you probably won't have that if you're presenting this to another person. You would just have the frequencies, but you can still see that the highest frequencies are towards the low end.